Okay, so on to the final challenges of this very tricky topic. Number one, going backwards. So you might want to solve equations that are like this. We've got that something to the power of 3 over 4 is 27. So we're actually kind of trying to go backwards here. We're saying that we have got some number and we're doing it to the power of 3 over 4 and we got 27. Well, let's think about what's going on inside this arrow here. If we're doing something to the power of 3 over 4. We know that the power of 3 over 4 means two things. It means doing the fourth root and then it means cubing. So we're taking a number. The first thing that we usually do is take the fourth root, which looks like this, and then we're cubing, which looks like this, and the answer that we've got is 27. We're trying to go backwards. So if you're going to go backwards, you're not going to be doing cubing. Instead, you're going to do the inverse of that, which is cube rooting. I don't know why I wrote 3 in there. So that's the inverse. And instead of doing the fourth root, the inverse of the fourth root is the fourth power. So to go back to the original thing, we're undoing it by doing a cube rooting, to undo the cubing, and we're doing a power of 4 to undo the fourth root. So let's have a look at trying that on this question, and I might show you why it works as well. Let's just quickly erase this. So the first thing that I'm going to do is undo the cubing by cube rooting. So let's do a cube root on both sides. When I cube root both sides, I will just get the x to the quarter, and the cube root of 27 is 3. The reason you get x to the quarter is because x to the 3/4, if you're cubing it, you're doing 3/4 times a third. 3/4 times a third, the 3's cancel, and you just get a quarter, or you could say it's 3 over 12, which is a quarter. Now that we're at that stage that we have, we're going to do the last part, which is the opposite, which is to do the opposite of the fourth root, which is the power of 4. I guess I should have written over here, this is the power of 4, and this is the cube root as the inverse. So I'm going to do the power of 4 over here. I'm going to do a little box and say I'm doing it to the power of 4. 3 to the power of 4 is 81. And that will just give me what x is. And that works because if you're doing x to the power of a quarter, all to the power of 4, the quarter multiplied by the 4 just gives you to the power of 1. Now there's another way you could think about this, okay? I'm going to see if I can sort of squeeze it in. I'll rub it out afterwards. I'll put it in down here. We have x to the power of 3 over 4, and we want to go to x to the power of 1. Well, if that's equal to 27, I guess what I could do is I could do x to the power of 3/4. What should that power be here that will give me x to the power of 1? Well, it's 4 over 3. If I do both sides of the equation to the power of 4 over 3, like I have done, you see I've got both things to the power of 4 over 3, you would be left with the left-hand side 3/4 times 4/3. 3/4 times 4/3, the 3's cancel and the 4's cancel and you just get 1. Or you could think about it as 12 over 12, and 12 over 12 is also 1. So we would just get that x is equal to, and then you can do your 27 to the power of 4 over 3, that's the cube root, and doing it to the power of 4, the cube root, and to the power of 4, and we get 81. Now we can check that this all works, because if I do on my calculator 81 to the power of 3/4, so I've replaced where x is, we do get the answer 27, so we have solved that equation by going backwards. So I'm just going to erase this work that we've got down here. I'm probably going to do one of them in this method up here, which I'll do like this, and then this one I'm going to use this method down here. So this one we've got n to the power of 2 over 3 equals 4. Well, this is cube rooting, so to find out what n is, I'm obviously going to have to cube both sides, so that will give me that n squared is going to be equal to 4 cubed. Let's get it in red. I could also, I could square root both sides if I wanted to first to get rid of the 2, but I'm going to get rid of this 3 because I think it's going to keep it quite small. I'll just show you there's a different approach. So I'm going to cube both sides, which gives me 64, and that's n squared, because when I cube this side, I go from 2 over 3, I times it by 3, and I get 2. And then I'm just going to square root both sides, and I get 8. Now if we did it the other way, if we had n to the 2 over 3 equals 4, if I first of all square rooted both sides, I would get n to the third equals 2, and then I would cube both sides, and I would still come up with the answer 8. I am going to do the other method because I do want to show you both ways. If I did the other method, I could do n to the 2 over 3. That needs to go to the power of 3 over 2. So the 4 also needs to go to the power of 3 over 2. This was the power that I've added in. And 4 to the power of 3 over 2 is the square root of 4 cubed, which is 8. So this one I'm going to try and do in one fell swoop. I'm going to do a power that I'm going to do to get it as y to the power of 1. It's going to be minus 2/3. Well, to get it to become a positive, it's going to have to be a minus 3 over 2. So I'm going to do 9 over 25 to the power of minus 3 over 2. It's going to make that 3 a little bit clearer. Think about what happens here. The negative times the negative gives you the positive, so we're just going to get y. That's what we're aiming for. And the 2/3 times 3 over 2 does give you power of 1. So I just need to do this final bit. Let me see how quickly I can do this. The negative is going to be the reciprocal, and then this is going to be the square root. So I'm going to take the reciprocal and I'm going to square root it. Reciprocal would be 25 over 9, but if I square root it, I'm going to get 5 over 3. So I've done the negative, I've done the 2. My last thing is just to do to the power of 3. And 5 cubed is 125, and 3 cubed is 27. So my answer for this is that y is 125 over 27. I'll show you that it works. If I do 125 over 27, and I do it to the power of, I believe it was minus 2/3. I don't think I pressed the power button. There we go, minus 2/3. We get 0.36, and 0.36 is 9 over 25. So there's one here for you to have a go at, and then we're going to try an exam question together as well. So we'll try this one nice and quick. I'm going to do both sides to the power of the 3 over 4, the reciprocal of this 4 over 3. So it will be a to the 4 over 3 to the 3 over 4, which will just give me a. But I need to make sure I do the same thing to both sides of the equation, just like we always did. So I'm going to do the 4th root, and then I'm going to cube it. The 4th root will be 2 and 3, and then I'm going to cube it, which will be 8 and 27. So hopefully you got the answer, 8 over 27. Now this is what I would call probably like a grade 8 or 9 question, because I think it's quite tricky. It's only worth 2 marks though, so they're quite harsh with marks towards the end of the exam. It says here, given that x to the power of 2/3 equals 12, and x is greater than 0, find the value of x in the form a root b, where a and b are integers. Oh, that's probably reminded me something. When we're doing the square rooting that we had here, that's meant that I've missed some solutions. We should also have said that x could be plus or minus when we did the square rooting, okay? If you do cube rooting though, you don't need to worry about that. So I think we also did some square rooting over here, didn't we? Yeah, we did some square rooting to get the reciprocal. So I think this could also be plus or minus as well. If it's cube rooting, which like we did here, and the 4th rooting, we also would need to have plus or minus. So that's my mistake. If you take a square root or 4th root, or 6th root, of course, an even root, you must have plus or minus. But that's because we're actually solving an equation. We were the people that was doing the square rooting, unlike in the earlier questions. So the reason I've said that is because it says that x is greater than 0, and that's made me think, oh, there's probably going to be 2 answers. There's going to be the plus version and the minus version. So let's see how it goes with this one. My apologies for that part. Given that x equals 2 over 3, given that x to the power of 2 over 3 equals 12, find the value of x in the form a root b, where a and b are integers. So we have x to the power of 2 over 3 equals 12. I'm going to do the technique where I'm going to do both sides to the power of 3 over 2. So I'm going to be doing 12 to the power of 3 over 2. That's just going to give me x, and this is then going to be the square root of 12 all cubed. But because we're the one doing the square root of 12, there actually is the positive and negative version of that. But luckily, because they've said that x is greater than 0, we can actually just go straight ahead and just do the root 12 all being cubed. So sorry for me saying about that, but if they said that x was less than 0, you'd obviously take the negative square root there. Now, like I said earlier, you're going to want to simplify these thirds. Now we know that root 12 can be written as 2 root 3. So this is going to be 2 root 3 cubed. That's 2 root 3 times 2 root 3 times 2 root 3. And the 2 times 2 times 2 times 2 is 8. The root 3 times the root 3 is a 3, and we have another root 3. So our answer is 24 root 3. Pretty tricky question there because it again brings surds into the question. So unlike the earlier questions, we were the one that was saying, cool, let's do a square root at this stage. So because we were the ones that were doing the square root, that's why there could be a plus and minus solution for this one, and this one, because all of these ones had a squaring or fourth root with them. Okay, in the last section of videos, we're going to do the second challenging skill, which is called matching the bases, or that's at least what I call it. And then we're going to do three more exam questions in that section. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.